Alright, let's look at page 1 of our study guide. At the very beginning, we're looking at the parts of the circle. The very first thing it asks us to find is the center. Okay, center is going to be point P. Next, we have a radius. We're looking for one radius, but if you'll notice, we have several. So let's outline those in red. We have PM as a radius, we have PL as a radius, and we have PN as a radius. So you could put any of these. If you want to do the singular one, we'll just do PM. Since this is a line segment, put the little bar above it. Now the diameter goes through the center of the circle, touching both sides of the circle. Now, we have two radii, PN and PL. If you put those two together, they form a straight line that goes through the center of the circle. That's going to be our diameter, LN. But again, it's a segment, so put the line above it. Now a chord is a segment inside of the circle, and it touches two sides of the circle. And again, it's inside. So right here, LM is our chord. Now the secant line is going to go outside the circle, touching two sides of the circle. So if you'll notice right here, JL touches two sides of the circle and goes outside the circle. So JL. Now the tangent line is going to touch the circle in one place only, on the outside. So notice that JN does exactly that. So JN is our tangent line. A central angle is going to start at the center for its vertex, and then it's going to go to two sides. So looking right here, I'll try to highlight this in pink on the outside. Okay, angle LPM is our central angle. Now an inscribed angle is also going to touch two sides of the circle, but it's going to have a vertex point on the circle. So as I look through, I can see that KLN is my inscribed angle. Now a minor arc, we have options for that. We can do arc LM. We could also do MN. We could do NK, or we can do KL. All of those are minor arcs. Remember, minor arcs are always named using two letters. A major arc, on the other hand, is going to be greater than 180 degrees, and so we need three letters to name those. So if we want to do greater than 180 degrees, we could do NLK. Notice that is most of the circle. So it's greater than 180. A semicircle is going to be around our diameter. So my semicircle here is going to be with my diameter NL, NKL, or I can do NML. Either one would be a semicircle, and that one's equal to 180 degrees. Now on number 2, we're asked to find the area and the circumference of the circle on the right. Now to find the area, we're going to use our formula pi times the radius squared. Since the circle on the right has a diameter, to find the circumference, we'll use pi times the diameter. So pi times the diameter will be pi times 16 6/10. Your calculator actually has a pi button that you can hit and multiply it to 16 6/10. Let's go ahead and round to 2 decimal places, and we'll get 52 15/100. Since we're talking about meters, that'll be our unit of measure. Now to find the area, we want to multiply pi times our radius squared. Now if we have a diameter of 16 6/10, to find the radius, we'll simply divide it by 2. 2 into 16 and 2 into 6 will give us 8 3/10 squared. So once again, you can use your pi button times your radius, which is 8 3/10, and we're going to square that. Let's go out 2 decimal places again, and the area is 216 42/100. Since we're talking about area, the unit of measure needs to be squared, so square meters. Okay, moving on, number 3. This is find the radius of a circle with a circumference of 106 and 8100 centimeters. The circumference formula with radius is 2 times pi times the radius. So I know the circumference is 106 and 8100ths. So in order to solve for the radius right here, I'm going to have to divide both sides by 2 pi. Because the 2 and the pi will cancel out, giving me my radius. So what I have here is 106 and 8100ths, and I'm going to divide it by 2 pi. And that's going to give me, if I go 2 decimal places again, that'll give me 16 and 999 thousandths. The 9 will keep rounding the tens up until we get to 17. Since it's centimeters, my answer will be 17 centimeters. Now look at my calculator right here so that you can see how I rounded. You see how you had the 9 will round that 9 up to a 10, which will round that 9 up to a 10, which will round the 6 up to a 7. Number 4, find the diameter of a circle with an area of 95 and 300 square feet. Now the area formula only has radius, so we'll deal with the diameter in a moment. The area is 95 and 300ths, and then pi times the radius squared. Let's get the radius by itself by dividing both sides by pi. Okay, take your calculator, 95 and 300ths divided by pi. And then to undo the square, we'll take the square root. So the radius is equal to 5 5/10. And since we're talking about square feet, put feet as your unit of measure. Now go back and make sure you've answered the question. It actually asks for the diameter of the circle. So if the radius is 5 5/10, the diameter will be 5 5/10 times 2, which is 11. So the diameter is equal to 11 feet. Number 5, we have find the circumference of a circle with an area. So let's go ahead and use our area formula to find our radius, and then we'll plug in the radius to the circumference formula. So area is equal to pi times the radius squared. Now the area is 254 and 4700ths. Let's solve this the same way we did before by dividing both sides by pi and then taking the square root. So we have 254 and 4700ths divided by pi. Okay, which rounds to 81. So r squared equals 81. So my radius is equal to 9 inches. Now it asked me to find the circumference, and I have found the radius. So we want to use the circumference formula that has radius in it, which is 2 times pi times the radius. So that's going to be 2 times pi times 9. And if we go out 2 decimal places, the circumference is 56 and 5500ths, and this is going to be inches as well. Okay, now number 6, we're finding the area with a circumference of 30 pi meters. Now since we're finding area, we have to have radius for area. With circumference, we could have radius or diameter, but to find area, we have to have radius. So if we're given the circumference, it would only make sense for us to use the formula 2 pi r, so we could solve for r. Now the circumference is 30 pi. So let's replace c with 30 pi. Now let's get r by itself by dividing both sides by 2 pi. Pi divided by pi and 2 divided by 2 is 1r. Pi divided by pi is 1, and 30 divided by 2 is 15. So that means my radius is 15 meters. Now I'm going to use my radius to find my area now. So pi times the radius squared. We know 15 times 15 is 225 times our pi value. I'm going to leave my area in terms of pi since my circumference was left in terms of pi. Since we have meters, I know that this will be square meters. Now if you actually multiplied it out, 225 times pi, you'd get 706 and 86 square meters. Okay, now at the very bottom we're talking about finding the measure of each arc. So if you remember, if you have a central angle, the measure of the arc is going to be equal to the measure of the central angle. So as I look, I see that EC is a diameter. So I know from E all the way around to C is a semicircle, or 180 degrees. So I can take 180 and I can subtract 79 and 53, which is 132. So 180 minus 132 is 48 degrees. So I know that AB is 48 degrees. Now, I also noticed that BZD is 90 degrees, so that means arc BD is 90 degrees. So I can do 90 minus 53 is 37 degrees. So I know that CD is 37 degrees. Now I can find ED because I have all the other arcs. I can take 79, 48, 53, and 37, and I can add those together to get 217. So 79 plus 48 plus 53 plus 37 is equal to 217. Or I could have done 180, which is my diameter, plus 37. That probably would have been the smarter thing to do. Now I can do 360 degrees minus 217 degrees. And that means ED is 143 degrees. Now let's answer the questions. The measure of arc CD, we already found that, is 37 degrees. The measure of arc AB, which is going to be right here, 48 degrees. The measure of ED, which is going to be this arc down here, that's 143 degrees. The measure of arc EB, okay, it's going to be 79 plus 48. So 79 degrees plus 48 degrees, which is 127 degrees. Now we're finding BDE, 3 letters. So BDE. So that's going to be 53 plus 37 plus 143. Okay, and that's going to give us 243 degrees. See, the 3 letters indicates a major arc. So since we have a major arc, it has to be greater than 180. So DEC, let's see where we're going with that. DE is 143. Then E to A to C. Well, that's going to be everything but our 37 degree angle, isn't it? Okay, so D to E is 143 and E to C is 180 degrees. That's probably going to be our easiest bet. So 323 degrees. And that's going to be page 1.